first couple days we're going to be reviewing some Algebra 2 and pre-calc concepts. So the first thing we're going to start reviewing with is exponents. So let's start there. So if I have the cube root of 64 squared, there's two different ways I could write this. You might also see it like 64 to the 2/3, like that. But in this case, if I have the cube root of 64, we know how to find the cube root of 64. What is the cube root of 64? 4. And then it's 4 squared then. So our answer then is 16. So we're just simplifying it down. So part B is written with a rational exponent, we call it, so a fraction for an exponent. So if we want to write it with radicals, we say the bottom number is the type of root that we have. So it's going to be the cube root of -8, and that top number is the power that we have. So it's all going to be raised to the 2 from there. So we can take the cube root of -8, that's going to be -2. So we would have -2 in parentheses squared. So -2 squared then is 4. So just one thing at a time. I usually do the root first because it makes it a smaller number instead of raising something to a power and making it bigger. All right, so we can have combinations of those. So I have like 25 to the 1/2 all over 4 to the -3/2. We just do one thing at a time. So on this one, 25 to the 1/2 is 25 under a square root. I'm dividing by 4 to the -3/2. So do you guys remember what a negative exponent does to our problem? Yeah, like it will bring it up to the top. It could become 4 to the 3/2. We could do that. A negative exponent in general means like we take the reciprocal of the base. So if you see 4 to the -3/2, it's really a 1/4 to the 3/2. So the way that I wrote it for students is I always said, you know, like when you see a negative, it really means 1/. So we do 1/. Something. So I'm doing 1/4 to the +3/2. So like Ari's saying, what this actually does is when we, you know, take the square root of 25, so we have 5, and when we write divided by 1/4 to the 3/2, it actually flips it to the top. Okay, so when you have a negative exponent on the denominator, you can write it as a positive exponent on the numerator. So let's find the 4 to the 3/2. So that means I have the square root of 4, and I'm cubing it. So I have 5 divided by 1/8, which is the same as 5 times 8/1, which becomes 40. So the next one has a lot of e's in the problem, so don't let the e's throw you. It's just like if we had x's. So think about all the rules when we would have like x's in the numerator and denominator. Like if I had like x to the 7th over 3x quantity squared times 4x to the 5th. Like think about all the things that you would have to do in a problem like that. You would probably have to get everything so there's only one x written and it's all to 1 power, right? We're going to do the same process with these e's. So the first thing we have is 2e cubed. So what that is 2e times 2e times 2e. So what is 2e times 2e times 2e? Yeah, 8e to the 3. Yep, 8e cubed. All over. And so I have the square root of e to the 5. So that's going to be e. That square root has a little invisible 2 with it, right? So it's e raised to the 5/2. Times e raised to the 9/3. Well, what is 9/3? 3. So we have 8e to the 3 over e to the 5/2 times e to the 3. So in this case, it's kind of nice for us because we have e to the 3 on top, but we also have e to the 3 on the bottom. So then those are going to cancel each other out, right? So those are gone. So you could write your final answer as 8 over e to the 5/2, or you could say 8e to the -5/2. That would be an acceptable answer as well. So I didn't say anything like you can't have negative exponents in your answer, so I think that's fine. Okay, in calculus we're going to do a lot of that. We're going to do lots of things with powers in particular, so we're going to have to be using negative exponents and knowing what those negative exponents mean. Okay, but the frustrating thing for AP calculus is in the end you take a test and, you know, most of it's multiple choice. There's some free response as well. But the multiple choice parts sometimes aren't written in the same way. So there's lots of ways I could write that answer. Like I gave you 2 of them. Think about all the other ways. Like if I had 8 over e to the 5 over 2, that's the square root of e to the 5th, which would actually be like e to the, think how many pairs of e's we have. We have 2 pairs, 1 left over, which is the same as 8 square root of e all over e cubed. I mean, that is a lot of different ways to write that answer, isn't it? So other methods, other ways. So it's kind of scary that you can write it lots of different ways. And that's what's frustrating for AP Calc students a lot of times, because their answer is the same, but it doesn't look the same. All right, so it says solve the inequalities using critical values and a number line. So the first thing we have is 4x squared is less than or equal to x. So when I have 4x squared is less than or equal to x, even if I just had equal, okay, what do you think we do for the first step? Everybody always says it. This is why I tricked you. I set you up, Ari, to fail there. So that's mean of me. We don't divide by x. Yeah, what do you think, Caitlin? We subtract the x over. Because if we just divide by x, let me show you what we would do if we divided by x. We would get 4x equals 1, which gives us an answer, 1/4. And that is one of the answers, but it's not the only answer. Okay, so what we have to do is we have to get everything on one side. So we're going to subtract the x over. And we're going to factor out the common factor, which is x. And we're trying to find critical values. So this is where things are equal. So we're using an equal sign for critical values. So if I just had equals 0, I get 2 answers, not 1, right? I get x equals 0, and I get 4x minus 1 equals 0. So x equals 1/4. So which answer did Ari leave off when we divided by x? 0, yeah. So we left off 0. So that, a lot of people will do that a lot, especially when it's like sine squared x equals sine of x. That's like a classic one that people will forget one of the answers on that as well. Okay, so now we put it on a number line. So we put 0 and 1/4 in the order that they go. And we kind of test in each interval. So we're seeing if our statement's true or false. So you could test all the way back in the original, or you can test in the factored form with the less than or equals to 0. So we're testing right there. So if I test -1 in that, I would have -1 times some kind of negative number, -5, right? Do you guys see that? What is a negative times a negative? A positive. Is that less than or equal to 0? No. So this would not work with -1. Okay, so let's try some other things. Let's say 1/8. Ooh, a little tricky, but that's okay, we got this. So 1/8 is positive times 4 over 8 is 1/2. 1/2 minus 1 is negative. So a positive number times a negative number is negative. Is that less than or equal to 0? Yes, so that works. All right, and the next one, if I try 1, I get positive times positive is positive. So that is that less than or equal to 0? No, it doesn't work. So we want everything that does work. So any number that we would have picked between 0 and 1/4 would work then. How about the endpoints? If I plug in 0, does it work? And if I plug in 1/4, does it work? Yeah, those are the numbers that made it equal to 0, right? So those are the ones, those ones do make it work. Now if it just said less than x, or less than 0 as we simplified, right, then we wouldn't include those.
So if it works, it's a closed dot?
Yeah, if it works, it's filled in. It's kind of like that's a shaded, that's one of the solution set as well, so we have to shade it as well. So it's going to be bracket 0 to 1/4 is how we would write that in interval notation. Okay, I usually prefer interval notation. Some of you guys might write it like 0 is less than or equal to, x, which is less than or equal to 1/4. I feel like that's longer. I like to write it the shortest way possible. All right, now if you kind of outsmart the system, some of you guys are going to be really good at this, and you know your shapes of graphs. Like when we look right here, 4x squared minus x. 4x squared minus x. If I set that equal to y and I graphed it on my calculator, what shape is that? It's a parabola. Is it an upwards parabola or a downwards parabola? Upwards. So what these numbers that we found, that 0 and 1/4, what those are the x-intercepts. So if we have an upwards parabola, it's like that. And what we're asking is we're saying, well, when are our y values less than or equal to 0? So the line y equals 0 is right here. It's the x-axis. So when are we below the x-axis? We're below the x-axis from here to here. So that's why it was from 0 to 1/4. Does that make sense? So the next one is going to be a cubic function, which is going to look like that, right? So let's think about it. So let's get everything on one side. And we want to factor it. You guys remember how to factor 4 terms? I call it split the middle, factor by grouping. So we pull out the common factor of x squared. When I do, I have x plus 4. I know I still want to have x plus 4 over here. So I pull out a negative 1 in order to get that. So what we're doing now is we're factor by grouping. This x plus 4 is now a common factor. It's now the GCF. So we pull that all the way to the front. So the x plus 4 goes all the way to the front. And we write what's left. So we have x squared minus 1 left, which also factors. X minus 1, x plus 1. Perfect.
Isn't there a rule about how you have, how if you are splitting it and then you have 2 of the same?
Yeah, so if you have 2 of the same, so we do have 2 of the same. That's now the GCF, so when we pull that to the front, that's right here. It's the common factor that's been pulled out. Does that make sense? So we just write it once. We don't have to write it twice. So then we get critical values of -4, 1, and -1. So we do our number line. So -4, -1, and 1. And you can outsmart the system. That's why I was saying, if you know the shape of the graph, like, you're really good. Because you know it has to be one of those, like, up and down ones. So it's going to go, it would go, like, through -4, through -1, and then back up. Okay. Now, some of them are tricky. Some of them have, like, multiplicity. Like, if 1 was listed twice as an answer, there's weird things that go on there. You might just want to check then. Yeah, it bounces then, right? So we're deciding we want to know where it's greater than or equal to 0. So where is it above the axis? From -4 to -1, and from 1 on. So we were below, above, below, above. So I do minus, plus, minus, plus. So I know I'm below the axis, above, below, and then above. And they are included. Yep, the endpoints are shaded. So it's going to be bracket -1 to -4 to -1, bracket, union, bracket 1 to infinity, and then a parenthesis on the infinity. Do you guys remember we never equal infinity, so we just do a parenthesis there. Feeling pretty good with this? We do a lot of critical values in calculus. A lot. All right, so the next one. So I have 2x squared plus 4x minus 3 is less than or equal to 0. I call this my welcome to calculus problem. Because try as you might, so kind of look up here, you don't have to write. You put 2x and x, and we're like, okay, I'm going to put the 3 here and the 1 here. And then when we look at the outer and inner swoops, those outer and inner swoops need to combine to be the 4x. My outer swoop is going to be 2x, my inner swoop is 3x. Can I combine 2 and 3 to ever get? Like, okay, that didn't work. Let's switch things. So instead of doing the 3 and the 1 in the order I just had, I'm going to do a 1 and a 3. Does that work? No. So are we done? Are we like, oh, no solution? No. This is upwards parabola. It could dip below the axis still, right? It could be at irrational numbers. Like there could be square roots in the answer. So how do I do it? The quadratic formula. All right, can you all write down the quadratic formula? Do you remember it? -b plus or minus the square root of b squared minus 4ac by 2a divided by 2a. So you might know it to pop goes the weasel. My Algebra 2 students know it to get low. It's weird. The things you can find on YouTube. So let's see. So we're going to go ahead and plug in. So we have -4 plus or minus the square root of b squared is 16 minus 4 times a times c all over 2 times a, so 2 times 2. So I go ahead and square the b as I put it in. So I have -4 plus or minus 16 plus 24 is 40, so square root of 40 all over 4 So I get negative 4 plus or minus square root of 40 is 2 root 10, because 4 and 10, right? So 2 root 10 all over 4. And then really this 4 goes into both things. It goes in here and it goes in here. So we can reduce down by 4 everywhere. Or if we want to keep it all as one solid fraction, like all together, we just reduce everything by what these three numbers have in common. So 4, 2, and 4, what's their GCF? 2. So we can reduce everything by 2. And I tutor a girl whose teacher had her draw like little hearts every single time. Isn't that cute? So you can draw a little heart if you want to. So you remember that that 4 goes into both things. So I have negative 1. Oh, not negative 1. What am I talking about? You reduce all of them by 2. So I'm going to have negative 2 plus or minus 1. So I'm just going to write root 10 all over 2. And really, you don't have to find the decimal approximations for those. You can. You don't have to. Because we know which one's bigger and which one's smaller, right? It's going to be negative 2 minus root 10 all over 2. And it's going to be negative 2 plus root 10 all over 2. Makes sense why it's in that order? And we know the shape. So we don't even have to think, oh, what number's between those? What number's bigger than those? Like, we don't have to think about it. Because it's a parabola and it's upwards, and we're trying to figure out where it's less than or equal to 0. So where is it going to be less than or equal to 0? Yeah, in between, right? So it's going to be from here to here. So our answer is going to be negative 2 minus root 10 all over 2, comma, negative 2 plus root 10 all over 2, like that. So you could find the decimal approximations. I think I did earlier. It was negative point, no wait, hang on. Negative 2.581 to 0.581, I believe, is what the decimal approximations are. Okay, so the next one. So I give you a hint on this. It says you will need to use x equals 0 as a critical value too. So critical values come from where your equation is equal and undefined. Okay, and there's a whole long explanation of why this would be true. But let's just think about 1 over x equaling 0. Is 1 over x ever equal to 0? No. But if I wanted to find where it was less than or equal to 0, what numbers would I plug into 1 over x to make it less than or equal to 0? Negative numbers, right? What numbers would I plug in to make it greater than or equal to 0? Positive numbers. So shouldn't x equals 0 be a critical number? Does that make sense? If there's an important, something changes there. We need it on our number line because everything to the left of it makes the number negative, and everything to the right of it makes the number positive. So we have to include that on our number line. So critical values come from not only where it makes the equation equal, but also where the equation is undefined. Okay, so we have to include those as well. So, a little tricky. Are we ready for this? Let's say we set it equal. And I have fraction phobia. Oh, fractions are the worst. I don't. I love fractions, actually. They make your life so much easier if you have an understanding of fractions. But let's say I have fraction phobia, and I want to clear out fractions. I do not want to have an x on the denominator. I don't want to have that 4. What do I multiply by?
4x.
I multiply everything through by 4x, exactly. So I'm going to get 4x squared plus, the x's are going to reduce on the next one, so 4 equals, the 4's reduce, 17x. So I have 4x squared minus 17x plus 4 equals 0.
Multiply by x because there's x on the other side.
What are you saying? Why can I multiply by x?
I mean, like, why are you multiplying by x? It's not about it.
It's because I want to clear this one as well. Yeah,
Oh.
that denominator as well. Yeah. And usually we don't multiply it through on both sides of the equation by like x because it, like, what if x is 0? Then it's going to mess everything up. Well, that's why x is going to be a critical value as well. All right, so now we factor. So in the other class we were talking about, like, what if we put 2x and 2x? So let me kind of give you some factoring basics in case you've forgotten. I enjoy teaching factoring. I missed out on having many of you guys for Algebra 2. There's some shortcuts. some things that make factoring so much easier if you understand why it's true. So looking at 4x squared minus 17x plus 4, is there a GCF? No, there's nothing that I can pull out that is in common to all of those. You guys agree? Okay, so let's think about numbers. If I have 100, and I know that 10 goes into 100, and I know that 2 is a factor of 10, does 2 therefore go into 100? Yeah, that's kind of how factors work with this as well. If I don't have a GCF here, I'm not going to have a GCF anywhere else. So if I messed up and I decided that I was going to do 2x and 2x, my factors of 4 are 1 and 4 and 2 and 2. If I put a 1 and a 4 here, what do we have right here? We have a GCF of 2. What if I put a 2 and a 2? Again, GCF, right? I cannot have a GCF, so it cannot possibly be 2x and 2x. So that's hopefully what you guys will see right away, and you'll be like, oh, it has to be 4x and x, because my other one has 4. There's no way to get the 2x and 2x. So now using that same logic, I have possibilities of 1 and 4, 2 and 2. Can I do the 2 and 2? No. So I'm down to the 1 and 4. There's only one way that I can possibly place these. 1 here, 4 here. Do you guys see? Yeah, and then our outer and inner have to combine to be negative 17. So if they're both minus, we're good. We get negative 16 and negative 1. So they combine to be negative 17. So our critical values are going to be 1/4 and 4. So we also have the critical value of x equals 0. So don't forget that one. So I have 0, 1/4, and 4. And this one I'm going to guess that you don't know what this looks like. There's an asymptote in this one. So this is one where I would check. And I would just go all the way back to the original one. So if I'm checking in this original equation, whoa, does that make you dizzy? There we go, in that original equation right there. So let's try like -1. -1 minus 1 is -2. Is that less than 17 over 4? -2? Yeah, that's less than 17 over 4. All right, 1/8, ugh. 1/8 plus 1 divided by 1 over 8. What's 1 over 1/8? It's 8. It's the reciprocal, right? So 1/8 plus 8. So 8 and 1/8. Is that less than or equal to 17 over 4? It is not, right? Huh? Oh, just less than, sorry. Less than 17 over 4. How about the next one? So let's try 1. 1 plus 1, 2. Is that smaller than 17 over 4? Well, what's 17 over 4? It's a little bit more than 4 or something, right? So yes, it is. It doesn't always alternate, so don't just assume it alternates. A lot of times, but not always. All right, so 5. 5 plus 1/5, so we get 5 and 1/5. Is that smaller than 17 over 4? It's not. So that's our check marks. We only have the check marks on the left side and here. All right, endpoints. They don't work because it didn't say equal to. Now question, what if this did say less than or equal to? One of them would still remain open. 0, why? Because if you plug in 0 to check, it doesn't work. It gives you undefined, right? It doesn't say, oh, true statement, that side is equal to that side. Good to go. No, they're not equal. It's undefined. Okay, so in that case, you would fill in this one and this one if that was true, the 1/4 and the 4. All right, so, but we don't have. So our answer is going to be negative infinity to 0, union 1/4 to 4, and everything has parentheses. All right, continuing on. So equations of lines. So it says find the equation of the lines with the given characteristics. You may write your answer in slope-intercept form or point-slope form. Okay, so the big thing to know about this is point-slope form. Point-slope form is y minus y1 equals m times x minus x1. This is super important in calculus. This is why I chose to put this in a review section. Because sometimes you get the lovely m equals negative 31 over 7 through the point negative 3/5, comma, negative 5 over 51. Calculus is like that. But if I ask you to write the equation of the line, you know what you do? You write y plus 5 over 51 equals negative 31 over 7 times x plus 3/5. And you circle that. You're done. Okay? Because if I asked you to write it in slope-intercept form, y equals mx plus b, look how gross this is, everybody. Negative 3 over 7, you'd multiply it in. You'd get a denominator of 35. You would then subtract this over, and you'd have a denominator of 35 and 51 that you'd be getting common denominators for. Does that make you want to puke a little bit? It should make you want. We don't want to do that. So in AP Calc, we know that you know that process. We know that you know how to do it. You leave your answer in point slope form every single time. Okay? So if you mess up on the AP test and you go too far and you simplify but then you get something wrong, you don't get the point. You get it wrong. So just leave it like that. Okay, so let's skip to B. We don't have to do A. We'll do B. So our slope is going to be y2 minus y1 over x2 minus x1, so plus 1/2 then. So I get 5/6 divided by, well, 1/2 is 2/4. So 3/4 plus 2/4 is 5/4. So we get 5/6 divided by 5/4. So we flip it and do 4/5. And we reduce down. So we get 2/3. So that's our slope. And it's through either point that we want. It doesn't matter. So I'm going to do y minus 0 equals 2/3 times x minus a negative 1/2, so plus 1/2, like that. Done. So you can circle it. You can leave the 0 there. You could just write y. It doesn't matter. Don't you like point slope form now? You're like, oh, that's my friend. Everybody hated it in Algebra 2, but once you get to Calc, it's like, oh, I see the usefulness in point slope form. Yeah. You know why you do that? Because math teachers are lazy and we don't want to grade multiple solutions. So we always have you put in slope intercept because it's like one thing we have to check.
Well, and it's like
only
really
one
easy to
slope
read
intercept.
and see the line thing, but it's not
Yeah.
simplified.
Okay, so this one we need in the form y equals mx plus b because we need to see what the m is. We need to figure out what m is, right? So this one we're going to subtract the, that's a 5 there, it looks a little sloppy. I'm going to subtract that 2/3 over, so negative 2/3 x plus 10. And how do I get rid of my negative 1/5? Yeah, multiply by negative 5, which is really negative 5 over 1 if you want to write it as a fraction. So we get y equals 10 over 3x minus 50. And really the only thing that matters to us is the slope right here. You can kind of cross out everything else. We don't care where it crossed the y-axis. There's an infinite number of lines that are parallel to that. It could have crossed anywhere. So now we want perpendicular to that line. So our slope is not going to be 10 over 3. Yeah, we're going to flip it and make it the opposite. So negative 3 over 10. And we're through this point, negative 7 comma negative 3, so it's going to be y minus a negative 3, so plus 3 equals negative 3 over 10 times x minus a negative 7, so plus 7. And that's our equation. Done.
Was the slope originally just 10 over 3 or was it negative?
It was 10 over 3, yeah. So we make it the opposite, meaning plus becomes minus or minus becomes plus, and reciprocal. Yeah, it does kind of look, did I cross it out? It looked a little... All right, so solve the quadratic equations. I should have done this before we did the ones with inequalities, right? That would have been nice. But this one we would just subtract the 3x over, right? Just like before, we can't divide by x on both sides. So I have 7x squared minus 3x equals 0. I pull out the x. So I get x equals 0 and I get x equals, can you guys do it in your head? You add the 3 over 7, yeah, perfect. All right, same idea on B. We're just going to simplify first, try factor if possible. So I get 4x squared minus 8x minus 5x squared plus 5x. You guys all have plus 5x on your paper? Yep, equals 2. We start combining like terms, so I get negative x squared minus 3x equals 2. Then you can do a couple different things here. So some people don't like to have a negative x squared, so they would add the x squared to the other side and add the 3x to the other side. That's fine. But let's say I did subtract the 2 to the left side, because I was like, oh, that's the easiest thing to do in one step. Now I would just pull a negative 1 to the front, because I never like having a negative x squared to factor. It just kind of complicates things, right? So it's easier to do this way. So when we factor, we get x plus 2, and we get x plus 1. So that negative 1 out front is like useless. We're not worrying about that at all. It's just saying negative 1 times a number times another number equals 0. So x plus 2 could equal 0, or x plus 1 could equal 0, which gives us answers of negative 2 and negative 1. All right, makes sense. So we'll skip C. How about D?
Is that not separate?
What do you mean separate?
Like it's not under the radical.
Yeah, it's not under the radical. You could do a W substitution. Do you guys remember that? There are ways to square it. Like you could isolate the radical and square both sides. So you could do that. I think this one's easier to, if you notice that like you have the square root of x and that squared is x. So what some people will do is not even do the W substitution. They'll just be like, oh, well, if I have a square root of x and a square root of x, that's what multiplies to be x. And then I'd need 9 and 1 to make that outer and inner. Does it make sense? All right, some people do not recognize that though, so we'll start with the W substitution. So I'm going to say let W equal root x. If I squared both sides, I'd have W squared equals x. So it's fresh in your minds if you took Algebra 2 last year. Not so fresh if you haven't been in Algebra 2 in a while. So what we're going to do is the x is replaced with W squared. The square root of x is replaced with W. And the 9 is just like it is. So it's like that. That becomes a quadratic equation that we can then factor. So if I factor, I have W and W. And I have 9 and 1. I need minus and minus. So I get W equals 9 and I get W equals 1. But our original problem didn't have W in it, it had X. So writing the answer like W equals 9, W equals 1, and people will circle it from there. Like, we're not done because I don't know what W is if I started from the beginning, right? So we now replace and we say, well, W is square root of X. So square root of X is equal to 9 and square root of X is equal to 1. So I used to have this on the Algebra 2 final, this problem. And people would always be like, oh, plus or minus 3, plus or minus 1. And it's not. Like, how do you get the x by itself now? What do we have to do to both sides? We have to square it. So when we square both sides, what do we actually get? 81. Yeah. And 1. And you can check those. Both of them actually do work.
So whenever you have a square root, like you just had, you're going to always square instead of actually.
Yeah, to get rid of the square root. Yeah. All right, so looking at these next ones, so it says, combine the fractions using common denominators. So we know that x squared minus 1 is really x plus 1 times x minus 1. So you know if we had denominators that was like 2, 3, and 4, what would our common denominator be? 12. You guys know that it's not 24, right? 2 times 3 times 4. You guys all knew it was 12. Okay, so we don't have to like, we're getting the least common multiple. That's why it's called the least common denominator. So we're getting it as small as possible. So let's look at each of these denominators. Let's say what it has and what it's missing. So when I have x minus 3, so it has x minus 3, what factors is it missing that are in other denominators? X plus 1 and x minus 1, right? So we're going to write it, and we're going to have 2 times x plus 1 times x minus 1. And these are all going to be over what denominator? x minus 3 times x plus 1 times x minus 1. You can always leave the denominator factored. We actually like factored denominators. Okay, plus, so now we have the x part. Well, what does the x part have? It has a denominator of x plus 1. What denominators does it need still? X minus 3 and the x minus 1. Exactly. And then the last one, we have the 3. So we have the denominator of x plus 1 and x minus 1. What do we still need? Just the x minus 3. Okay, does that make sense? It's all over that same denominator. Oh, is it minus? Darn. Got me. Who got me? Okay. Oh, who said it first, though? Well, Anna gets it today. Next time she'll nudge you. You get a max of 5 per semester. All right, and then we would just simplify all this out. Okay, so I'm going to kind of do this speedily. If you just want to write ... it's fine. You know how to do this, right? So we're going to get 2 times x squared minus 1 plus x times x squared minus 4x plus 3 minus 3, I keep wanting to make that a plus, minus 3x plus 9. And it's all over that denominator, which I'll just write as little quote marks until the end. So we have 2x squared minus 2 plus x cubed minus 4x squared plus 3x minus 3x plus 9, all over quote marks. So the 3x's cancel. We get x cubed minus 2x squared plus 7, all over x minus 3, x plus 1, x minus 1. And that is our answer. Lovely, huh? Yeah, I didn't mean for it to be that messy, but, you know, whatever. All right, let's stop.